Good evening, everyone. So, welcome to my YouTube channel, Math Sutra. So, today we are going to see seventh lecture on infinite series. Today we will study the topic bounds for the remainder in the integral test. Integral test we have discussed in previous lecture. So, let's see what is this. So, today's topic is bounds for the remainder in the integral test. Okay. Suppose AK is a sequence of non-negative non-negative terms with AK is equal to Fk for all k belongs to natural number system where F is a continuous non-negative monotonically decreasing function of X for all X greater than equal to 1 and the series summation k goes to 1 to infinity AK converges to S. It means what? It means it means this series k goes to 1 to infinity. AK is convergent and k goes to 1 to infinity. AK is equal to S. Then the remainder Rn is equal to S minus Sn satisfies the inequalities n plus 1 infinity fx dx is less than Rn, that is less than n goes to infinity fx dx for all n belongs to n. Okay. So let's have its proof. So what is its proof? Let's prove it. Now, what is this? Is k goes to 1 to infinity, a is equal to s, and Sn is nothing but what is this? This is k goes to 1 to n ak. Okay. Therefore, what is Rn is equal to s minus Sn. What is this? This is an plus 1 plus a n plus 2 and so on like that. Okay. Now, what is a n plus 1 plus a n plus 2 plus a n plus 3 and continuing in this way? This is always greater than n plus 1 infinity fx dx. So this implies r n is greater than n plus 1 infinity fx dx. Let's say this is 1. So why this inequality is happening? It is very clear. I'm drawing a graph here. So you see this graph. This graph. This is x-axis. This is y-axis, and this is 0. So this is f is monotonically decreasing sequence. This is my fx, and what is this? This is my a1. This is my a2. Okay, and this will be somewhere an will be there, and an plus 1 will be here, and then an plus 2 will be here, and an plus 3 will be here, and it will be continuous. Okay, so here we can join this, and continue. We can proceed like that. Lower rectangle, we have this one, this one, this one. Now, sum of the upper triangle is greater than this area. Area under after an. What is the sum? The area of these rectangles. This one, then this one plus, and then this one plus, is greater than the area under the curve starting from here and the x-axis. Similarly, the area. So we got equation number 1 by this way. Now, if we take a lower rectangle and their area, what is their area? You sum them, and what is this? An plus 1, an plus 2, an plus 3. Okay. Then this will be less than this area, and goes to infinity fx dx. Okay. So what is this? This is again Rn. Okay. Now, so from 1 and 2, what we have? So from 1 and 2, from 1 and 2, we get what we get? What we get? Rn is less than, by 2 we have this one. Okay. By equation 1 we have this one. Okay. We have this one. Now, what is Rn? So we have this one, n plus 1 infinity fx dx. Rn is what? Put the value of Rn. This is s minus Sn. Okay. Sn. So now we solve it. So this implies Sn plus n1 plus 1 to infinity fx dx is less than Sn plus n to infinity fx dx for all n belongs to n. So this is true for any n belongs to n. So this is my result. Okay, let's say if double star. Earlier result you say star, that was in Rn. So this was in Rn. We have to prove that much only. So this is for all n belongs to n. Okay, let's say it star. So this is proved. But we have evaluated more. Okay, we have evaluated more. So this is up to this. Now we will do one exercise here. Example. Estimate the sum of the series summation 1 upon n square. Means this is 1 to infinity. Using the inequalities in double star and n is equal to 10. Solution. So this series is convergent. This series is convergent. Okay. Because n is equal to 2 you take in n is equal, p is equal to 2 you take in auxiliary series. So this series is convergent. Okay. Now what is the choice of fx? Fx you take 1 upon x square. Okay. Then f n is equal to 1 upon n square. Okay. For all n belongs to n. Okay. So this is continuous, non-negative, and monotonically decreasing. Okay. Monotonically decreasing. Now now what is 1 to n to infinity 1 fx dx, that is this is n to infinity 1 upon x square dx, that is limit epsilon tending to infinity n to epsilon 1 upon x square dx. So this is limit x tending to 0 1 minus x n to epsilon. This is limit epsilon tending to infinity 1 minus epsilon plus 1 upon n. So what is this? This is 1 upon n. Similarly, similarly, n plus 1 to infinity fx dx, what will be this? This is 1 upon n plus 1. Similar manner you can calculate. Okay. Now by double star we get what is this? This is S10 plus 1 upon 11 S S10 S10 plus 1 upon 10. Okay. So let's say this is 3, equation number 3. Taking S10 is equal to 1, 1 upon 4 plus 1 upon 8, sorry, 1 upon 9. 1 upon 16, 1 to 100. That is approximately how much it is? Approximately after calculating, it comes 1.54977. Okay. Okay. The equation 3 gives what it gives. You put this value. What is S10? 1.54977 plus 1 upon 11 as 1.4977 plus 1 upon 10. Okay. So what is this? So this is going to be 1.64068, and this is approx. This is, and what is this? This is 1.64977. Okay. Now, if we approximate S by taking the midpoint of both this one and this one, it means 1 upon 4068 and 1.64977. We find so what is the midpoint of both? It means what is the midpoint? It means 1.64068, 1.64977 by 2 is equal to 1.6452. Then 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 because this is the partial sum, we are approximating x by taking the mid value of this one. It means we are taking s is equal to this 1.652. And what is this? This is just a summation of the series. This is just a summation of the series. So this is what this implies. N goes to 1 to infinity, 1 upon n square approximated by 6452. Okay. Remark. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.